It is not the heat that kills you. There is a temperature where your sweat simply stops working, and it is lower than you think. Here are two real afternoons. Phoenix, 2023, 116 degrees. Larkana, Pakistan, 2015, 108. Both of them killed people. And for a human body, the cooler afternoon was the more dangerous one. That is not a story about who was tougher. It is a story about what the air was already carrying. You are a furnace. Sitting still, doing nothing at all, you are turning food into about 100 watts of heat, and you never get to switch it off. Walk up a hill, and that climbs into the hundreds. If you cannot dump that heat as fast as you make it, your core temperature climbs. Not gently, fatally, in hours. So your body has exits, 4 of them. Radiation, glowing heat away into cooler surroundings. Conduction, heat crossing into whatever you touch. Convection, air rolling past your skin and carrying warmth off. And evaporation, sweat turning into vapor and taking its heat with it. On a mild day, the first 3 do most of the work, and you never notice. But every one of those first 3 needs the same thing to be true. The world has to be cooler than you are. Your skin sits at around 95 degrees, so when the air climbs past that, something quietly awful happens. Radiation, conduction, and convection do not just stop helping, they reverse. Now the air is the hot thing, and you are what it is heating. 3 of your 4 exits just became entrances, which leaves exactly 1. Sweat! And on paper, sweat is more than enough. Evaporating a single gram of it carries off about 2,500 joules. A hard-working body can push out 2 liters an hour, and if every drop of that evaporates, it is over a kilowatt of cooling. You are carrying a bar heater's worth of air conditioning in your skin. If every drop of it evaporates. That is the whole video, hiding in 5 words, because evaporation is not something your body does to water. It is something the air agrees to. Air can only hold so much water vapor, and once it is nearly full, your sweat has nowhere to go. It beads, it runs down your back. It does absolutely nothing, because the heat only leaves when the water leaves. You have met this machine before, an evaporative cooler, the kind people call a swamp cooler, blows air across wet pads. In Arizona, it is magic. In Florida, it is a fan that makes the room damp. Same appliance, same physics, and it fails the instant the air is already carrying water. You are that machine, made of skin. Which is why the most useful instrument in this whole story is almost comically simple. Take a thermometer, put a wet sock over the bulb, blow air across it. The water evaporates. That cooling drags the reading down, and it settles at the coldest temperature evaporation can reach in that air. That is the wet bulb temperature. In dry air, the sock evaporates hard, and the reading falls a long way. In humid air, barely at all. And in air that is completely saturated, nothing evaporates at all. So the wet thermometer reads exactly the same as the dry one. Here is the thing. That thermometer in the wet sock is not really a weather instrument. It is a model of you. The wet bulb temperature is not how hot it feels. It is the size of your only remaining exhaust pipe. So there has to be a point where the pipe closes completely. When the wet bulb temperature reaches your own skin temperature, around 95 degrees, you cannot shed heat at all. Not in the shade, not with a bottle of water, not by resting. Your core just climbs. That 95-degree figure is famous, and you will see it quoted everywhere. It is also too high. 95 is a theoretical ceiling for an idealized body. Researchers at Penn State put real, young, healthy adults in a climate chamber and measured where their cooling actually broke down. It averaged 87 degrees wet bulb. Nobody reached 95. And a paper published this year went back through 6 lethal heat waves and found every single one of them happened below 95. Larkana sat at 88. Phoenix, in all that dry desert heat, only 76. And that is the answer to the puzzle we opened with. Phoenix was brutally hot, but the air was bone dry, so sweat evaporated and people could still cool themselves. Larkana was cooler and completely soaked, so sweat just sat on the skin doing nothing. The number on the forecast is not the danger. The air's appetite for water is. One last twist, and it is the practical one. A fan is not a cooling device. It is an evaporation accelerator. In humid heat, that is exactly what you need, and the research shows fans genuinely help. But in very hot, dry air, above about 104 degrees, that fan is blowing air hotter than your skin across your skin. And studies find it makes heat strain measurably worse. Same fan, opposite result. Because it was never cooling you, it was only ever helping you evaporate. So the next time a heat wave arrives, do not just read the temperature. Ask what the air is already carrying, because your body has only one way out, and the air decides how wide it is. One complex idea made simple every week.